Bismillahirrahmanirrahim, dear students. Assalamu alaikum. Topic of today's lecture is stack and queue abstract data structure. We have already learned what stack is. What is the basic concept of stack? Stack is in fact putting some things on top of another thing. So it will. It's just like the stack that we use in our real life. For example, stack of plates, stack of boxes, and whatever it is. So a stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real world stack, and we have seen what stack is and what was its value when we were studying the recursive operations, recursive functions. So whenever we are going to call a function from another function, we save the status of the previous function. When we save the status, by status I mean that which function called which function, or in other words, when a function will return or execute its body, it will return to which. How will it know that which function called it? So that is one application of stack. So you must recall lecture number 12, 13 and 14. Here we discussed there in detail. So now we will move forward. So as we have discussed some basics there, so our time has been saved. So we can place or remove a cord or plate or any element on the top. We can place on the top and we can remove from the top of the stack. So operations are possible from one end only, just from the top. So at any given time we can only access the top element of a stack. So here it is. So basically we have just two operations, push and pop. Peek is in fact a small subroutine of pop. Pop is in fact peep plus delete. So peek is included in this pop operation. So what does push mean? That whenever you've got a stack, you push things on the top of the elements that have been previously pushed on the stack, and so it means you're pushing elements there. So if there are, for example, 5 elements, which element will be taken out first? So the value that is last in, so it will be first out. So the value that was last in is on the top of the stack. So pop means that the value that is present on the top of the stack will be popped out, will be removed and returned. So as we discussed in the previous lecture, that basically there are two data types, arrays and linked lists. Means whenever you need to store more than one values in memory, so either you can store them on contiguous memory location or on different memory location, and you save the address of the next location in the with the previous value. So this concept is called linked list. So these are the basic two ways to use memory when we have got more than one value. So store, one is static and one is dynamic, and every other abstract data type, whether it is a list, whether it is stack, whether it is queue, or every data type, it can be implemented by either array or linked list. So we have already discussed what a list abstract data type is, and we saw both of its implementations in the form of arrays and in the form of linked list. Now here we will construct a stack, we will use a stack, we will implement a stack by using first array and then linked list. So in the first case it will be of a fixed size because arrays are basically static. In the second case, stack will grow or shrink. It means its size will be dynamic. So, but one thing must be kept in mind, that we know the upper limit, that even this dynamic stack will have an upper limit. So we have to mention that this dynamic stack can grow up to, for example, 500 values. So we have to mention what is the maximum size of the stack. So each and you all know that what are the merits and demerits of implementing something by arrays and linked list. So we are not going to discuss these as we have discussed them earlier. Now what is the basic operations? Push, pop and peek. What does push mean? To insert at the top of stack. Pop means to access and then remove the top of stack. Peek means just to access the top of stack without removal. So how will we know that stack is full and how will we know the stack is empty? So when stack is full, its top reaches the maximum limit. So we will check if top is equal to maximum limit, then it means stack is full, and when there is no element in the stack, it means stack is empty. Or in other words, you can say that in arrays, if top is at position 0, it means there is nothing. And in linked list, if top is pointing towards some null space, so it means it is empty. So you can do it in different ways. So here is the implementation of push operation in the form of array. So we have in push operation, we will always take a value. That value is to be inserted on the top of the stack. So first we will check the whether stack is full or not. So if top is equal to max, then we will return false, that your push was not successful. Otherwise, if there is room on in the stack, or in other words in the array, so you will increment the counter and place that value in the new position, and you will return true. So it is very simple algorithm. Let us simulate it. Maximum is 5, maximum limit is 5, and the value to be inserted is 10. So if top is equal to initially you see there is nothing in the stack. So if there is nothing, so I am going to start with position number 0. This is not index, this is in fact position of elements of array. So position, this position is 1, this is 2, this is 3, this is 4, this is 5, and 0 indicates that there is nothing. So why I consider it as position, because if I consider it as index, so index may be different in different programming languages. Some languages start index with 0, some with 1, some either allow to have minus indexes, I mean indexes with minus integer value. So let us be general, and suppose these are the positions. So positions start from 1 up to what is the maximum size, n or whatever it is. So if top is equal to max, top is not equal to max because there is nothing in the stack, and there is a maximum limit of 5, so it will not return false. So what it's going to do, it's going to increment the top, and then it's going to store this value on this index of array. So now top is pointing, or top means first position, and it contains 10. So first position means there is only one value in the stack, and the push is successful, so we will return true. Now there is another value. For example, if stack was full, what will happen? See, if stack is full and maximum limit of stack is 5, so top will be pointing to this value. By pointing, I don't mean a pointer; it's a general term. So if top is equal to max, yes, it is equal. So it means you cannot insert a new value. So it will return false, and it will do nothing more. Sorry. Now let's come to the pop operation. What does pop mean? Remove the value and return it. Return mean you have to read it. By read you mean you can use this value again now after removing from stack. So if there is nothing on the stack, so it means you cannot remove it because there is nothing. So if top is equal to 0 means there is nothing on the stack, then you will return null, means there was nothing to return. Otherwise, whatever the value is on the top, you will save it and you will return it. But to make that value not accessible, you will decrement this top index or position variable, whatever it is, whatever you call. Mean if I call here index or position, so just consider it at a position. Okay, now let us iterate it. So initially there is just one element on the top of stack, and that is 10. So what I am supposed to do, I am going to pop it. So if top is equal to 0, top is 1, so top is not 0, it means stack is not empty, it will not return null, it will save this 10 in some variable value. And because now by pop means that I am not going to access this value, so I will decrement the top. It means top is 0, there is nothing on the stack. We know there is 10, but we can only access the value that is pointed by this top variable. So this value is not accessible. Either there may be some values in these boxes, but if they are not accessible, it means they are nowhere. So I have got this value 10. I am going to return this value and pop will be successful. It's very easy. Now see, there is another example in which pop is empty. So if top is equal to 0, it will return nothing because there is nothing in stack. So it is very easy. Now what is peak operation? Peak operation means that whatever there is at top of stack, just return that value. So if there is nothing, for example, if top is equal to 0, so it will return null. So it means there is nothing on the top of stack. Otherwise, it will return whatever there is on the top of stack. It will return the value of this array stack which is at index or position top. So that is easy now. So we are not going to simulate it because it is very easy, and both these statements have been demonstrated in the pop operation. Now there is another, we told you that every data structure can be implemented by arrays as well as by linked list, and now we are going to implement this push operation using linked lists. So here is a simple algorithm. So I think there is a bit of mistake here. It's not a mistake. Just consider this algorithm. See, position means, see, in linked list there is no index. So whenever whenever stack is empty, so I noted that with the help of a variable that position is 0. So if I insert a value, means if I create a node and make a linked list, so I will increment this position. So position means the total number of elements in the stack. So if I push another value on the top of stack, so position will be incremented. So it means now there are two values in the stack. So if I change this variable by size, so it will be more appropriate, because in fact by this position variable I actually wanted to see what is the size, what is the current size of the stack. So size will be more appropriate than position, so it is not an error. You just consider it that we changed this position as size. Now here how we discuss the linked lists in a horizontal fashion. So if we and see, this is head, so to go to next node we say head dot next or top dot next, whatever the name of pointer is. So we know that stack is in a vertical position. So if we just orient it, we just rotate it in this form, so it is the same linked list. But you see, head dot next is pointing towards the value that is now considered to be at top of it, means it is the upward position, not the next position. So it doesn't matter whether you use the word next or top or up or forward. It is just your own programming practice. So I consider that whenever the list is in horizontal fashion, next pointer will be the most appropriate name, and whenever I am implementing it in a horizontal fashion, so up will be the most appropriate name. So it doesn't make any difference here. Now suppose value is 10 and you want to push it on top of this stack, and you know size is 3. So if size is equal to max, you know you have been given that maximum your stack can grow up to 4 values. So it means you haven't reached the maximum size yet. So if you had reached the maximum size, you would return false, but I will not do it. I will create a new node, because if size is not maximum, if size is not equal to maximum, it means there is still room in the stack for new node. So I will create a new node, and I will assign this value 10 to this node, and then I will see that whether there is no value on the stack, means stack is empty, or there is some value. So here in this condition, head is not null. It means there are some values in stack. So I will go to the second case. So in what is second case? Top dot up is equal to new node. So top dot up will now not point towards null. It will point towards this new node, and top will be equal to this new node because value has been this value is now on top of the stack. And you see now there are 4 elements here, so you are going to increase the size. As push is successful, you will return true. Now let's have another value. Size is equal to 4, and you have been asked to add value 15. So size is already 4, so size equal to max, it will return false, it will do nothing. And we haven't yet executed this line. So whenever size is 0, it means head is equal to null. You can also write it as when if size is 0, so it is no problem. So if size is equal to max, no, it is not equal, so it will create a new node. So, and it will assign this value 20, that is to be inserted in the list. Now if head is equal to null means if it is the first element to be inserted, then what we have to do, point this head to this new node, this. Now after this step, some steps are the same, that top will be equal to this new node, and as the previously size was 0, now size is 1, and so incrementation occurs here, and it will return true now. So it's very easy procedure. Now there linked list based implementation of pop. What we have done now, push. This was push operation, and now we are going towards the pop operation and the linked list based implementation. So this is the algorithm for pop operation if we are implementing it through linked list. So suppose we have got just only one value, size is just 1. So how can you pop this value? So first you see, if size equal to 0 means if there is nothing, so will return false because there is nothing to return. You can I think here in place of false, null will be more appropriate, so you can change it. Now value is equal to top that data because you are going to store that value, because you will return this value at the end if pop is successful, and you will delete this node so that this memory location can be used by other variables if needed. Now if size equal to 1 means if this is the only value, just release the top. So when you will delete this top, top and head will both point towards null. So if it is not automatically done, we can do it by another statement. It depends on the language which you are using. It supports it automatically assigns null or not. So if it doesn't, you can have this statement, otherwise you can omit it. And what will happen, size will reduce. Initially size was 1, now size is 0, and it will return the value. Alhamdulillah. Now there is second example in which there are 4 elements. So we know size is not equal to 0, so it will not return null. So please consider null in place of this false. I will make corrections in the PDF file. So value is equal to top that data. This 10 is to be popped. If size is equal to 1, no, size is not equal to 1, so it is go towards this else portion. So current node will point to head. So while current node dot up is not equal to top, you will move up. So until or unless you will move, this current node will move upward until its next or its upward is top. So it will move until it's up, means current node dot up is now equal to top, so it will stop. Now current node dot up is equal will become null. You see, you are going to delete this one, so you don't need this 10 because you have already saved it and you will return it at the end. So this will become new top. So before doing this, if this is going to become top, so its up must point towards null. So current node dot up is equal to null, and you have deleted the top. So we have done two operations in just one go, and then top is equal to current node, because this is now the top, and of course you will decrease the size because now there are three elements, and you will return the value that was removed, and you saved it 10. So it is quite easy. Now this was what stack is and how it is implemented in both ways, with the help of linked list or with the help of arrays. Now what are their uses? Stacks can be used for expression evaluation, and that is what we will do when we traverse the trees, and when we will study how parsing is done. And stacks are used to check parenthesis matching in an operation, and it is the second name for parsing, in fact. Stacks can be used for conversion from one form of expression to another, from infix to postfix and something like that. And stacks can be used for memory management as well. If you have studied COL, computer organization and assembly language, then you might have studied where the stack is located and what is the organization of computer memory. And stack data structures are also used in backtracking problems. You will study these when you will be in the topic of trees. And many compilers use stack for parsing the syntax of expression, and that I have already told you. And stack is used to reverse a string, or the other way, because it is very easy, because in string, if it is for example PAK, so if you want to reverse it, it is very easy, because you put all the values on stack. So first you push P and then A and then K, and now if you pop these values, these will be in reverse order, K, A, P. So it is used to reverse a string. It's very easy technique. Stacks are also used to give information about the active functions or subroutines. That is the point which we have discussed in detail in previous lecture, where we studied stack, and where we studied how a call stack or recursive stack is used. Similarly, when you are making some operations, these are all loaded on stack, and if you say, oh, I've done something wrong, so you undo. So what you undo, the most recent function, which means what is on the top of stack. So it is also this undo function is also uses the stack. Now there is a practice question for you. We have implemented a stack using arrays and single linked lists. So what you have to do now, you will construct an algorithm or algorithms for basic stack operations, mean peek, pop, push, if stack is implemented using a doubly linked list. In doubly linked list, there are two pointers, forward and next. So here, as linked list is implemented in a vertical fashion, so you can consider up and down instead of previous and next for your convenience. So one thing you have to remember, that implementation using doubly linked list is quite easier. Why? Because you can move in both directions. So consider that it is a hint for you people. Now we come to our next topic, that is queue. Now in Urdu, when we speak the words queue, when we speak the word Qatar, so it is in fact the same word, queue. Queue means Qatar. Qatar means the one who is coming first will be served first. So it is used in its literal meaning here. It is also an abstract data type. Unlike stack, queue is open at both ends. You can add into a queue at the back of the queue, and if you are at the front of the queue, so you will be served first and you can leave the queue. So it means insertion happens at one end, at the rear end, and deletion happens at the front end of the queue. So it means both the ends have some operations on it. Unlike stack, you can have push and pop operation just depending on the value that is on top. So it is named queue as it behaves just like a real world queue. one end is always used to insert data, and this operation will be called enqueue. Whenever we will use this terminology enqueue, it means we are going to insert data at end, and the other one and the other end is used to remove data. This operation is called dequeue. So dequeue means removing from front. So queue allows first in first serve or first in first out methodology. That is, the data item stored first will be accessed first. So you see, here is an example of queue. So the one at the front of queue is going to be served first, and the one at, and you can add, means if there is another man who wants to be in queue, so he cannot, it's very unethical that he breaks the queue and he stands in the front of the queue or in between something. So ethically he must stand at the end of the queue, means insertion happens at the rear end of the queue. Similarly, when the waiter takes orders in a hotel or a restaurant and he gives it to the chef, so what he does, there is a queue in fact. So the order that has been placed first will be cooked and served first. So that are general ethics. Now what are the basic operations? So first operation is enqueue, means if there are three items there and fourth one comes in, so it will join at the end. So it will add an item at the end. So this was the enqueue operation. So what is dequeue? Dequeue means that if the value at front is served, means if we need to delete it, so just this one value will be deleted, not the one at the end, the value at front. So enqueue happens at the rear end of the queue and dequeue happens on the front end. So if you compare both queue and stack, so there is a common thing that both doesn't support random access, because you see, you can insert at end, at this end, or you can read and delete from this end. So you cannot read 2, 3 and 4. You have to read 1 and then delete it. So 2 will become the front of the queue. So then you will read 2 and delete it, and then you can read 3 and delete it, and then you can read 4. So there is no random access. There is a sequential access. The same happens here. If you want to access the card with number 1 printed here, so first we have to pop this 4, then 3, then 2, and then. So random access is not supported here. This is a common point. But what is difference? Queue is first in, first out, while stack is last in, first out. And then this is thing that you know now. So a queue can be represented in the following way, that you can enter from one end of the queue and you can move out from the other end of the queue. So this is called the rear end and this is called the front end. So just like stack, queues can also be implemented either by arrays or linked lists. So in the first case, you know, arrays are of fixed size, they are static, and in the second case, stack can grow and shrink, or in other words, it is of dynamic size. So here is the representation of enqueue operation. So at first there are just 3 values. So this is the rear. So you can insert another value at rear. So if after insertion this new value will become, I mean this rear will point to this new value. Now in array based implementation, if you have got an array whose maximum size is max, means the maximum size of stack. So if you want to enqueue, means if you want to insert something at the rear end, so first you have to check that rear is equal to this maximum or not. Means if there is no room for new value, if queue is already filled, then you will return false. Otherwise, it will move to the next statement. It will increment the counter or index or position and will update it, and it will return true. So let's have it simulation. For example, this is stack, and what value you are going to insert. But first let me introduce you how it works. See, this is stack. Stack is in vertical position. It is an array starting from 1 to 5, and 0 indicates that this value is not in array if top is equal to 0. See, if you just make it in a horizontal fashion, it is still stack, because you are pointing by this top variable. So if just you change these variables and make them front and rear, so it will become queue. So insertion only happens at rear end, which was initially top, and we have already done how to push any value at top. So enqueue means how to push any value at rear. So it is the same operation, just like push. So we are not going to iterate it, because it is the same operation. So its simulation is same, its algorithm is same. Now how can linked list be used to implement this enqueue operation? You see, here is the stack. If you make it in a horizontal fashion, it will become like this. And what change you are going to do? This. See, this is stack where there are two pointers, head and top. So if you just change the name of these pointers and make it front and rear, so it will become queue. What happened in stack, that whenever you inserted a value, you inserted at top of stack, and whenever you insert a value in queue, you add at rear end. So it is in fact the same operation. So we are not going to discuss the enqueue operation, because it is just like push operation, both in array based implementation and in linked list based implementation. So that we have already discussed in the same lecture today, so we are not going to repeat it. It is just same. Dequeue operation is different, so we are going to discuss it in detail. What dequeue operation is, you see, there is a queue, there is a front end and there is a rear end, and dequeue means the value at front is to be removed and returned. So after this value is removed, the second value will become the front one, because now it is going to be served. So it is just a very simple concept. So how we are going to implement it? Suppose we have an array of 5 elements, and suppose our maximum size is also 5. So front is pointing towards 1 and rear towards 5. So by pointing here, I do not mean the pointer used in languages here. Okay. So these are just English words. You can say that front is the index or position, or it is pointing to this position. It is just the same. Now dequeue means to remove. So if there is nothing there, if this rear is equal to 0, means if there is nothing in the queue, so you can if there is nothing to remove, how can you remove something? So if rear is equal to 0, then you will return null. So that is very simple operation. So if rear is not equal to 0, it means there is at least one element in this queue. So you are going to remove that one. So removal will happen at front end. So you will first save this value, because this is going to be returned later on. So we will return. So we will save it. Now this is a very simple loop. For I is equal to front to rear minus 1, front is 1 and rear minus 1 is 4. So I will run from 1 to 4. But what will it do? It will copy. We do not need this 12. We do not need this 12. So if 21, 6, 8 and 5 are moved here, so that value at index or position 1 becomes 21, and at index 2 or position 2 becomes 6, and third value becomes 8, and fourth value becomes 5, and I decrement the rear counter, so its size will shrink, and we have in fact, and then we can return the value that was overwritten, 12. So this is what we are going to do here. So q of I is equal to q of I plus 1. It means 21 will be copied here, and after first iteration of for loop, I will be incremented. So q of I is equal to q of I plus 1, 6 will be copied here. Now you see 12 is gone because 12 has been overwritten. Again on the next iteration I will be pointing towards 3. So the value at I plus 1 position will be copied to this ith position. So 8 will be copied here, and then I is equal to 4 now, and we know that I can go maximum to this value of 4. So this is our last iteration. So 5 will be copied here. So on the next iteration I becomes 5 and condition becomes false, because for I is equal to front to rear minus 1, or in other words 1 to 4. So when I is iterated to 5, condition becomes false and we jump out of the loop. Now we know that one value has been removed, it has been overwritten, and the other values have been shifted. Yeah, you have already learned that in arrays are static. In arrays, if you delete something, you have to shift the values, and that was one of the disadvantages of array, and that is what happened here. We have shifted it with the help of both of these statements, loop and its body. Now we don't need this value. So if we just move this rear to 4, so it means this value cannot be now accessed. So even it is present, but it cannot be accessed. So it is just like it is not present here. So no worries, and we are going to return the value that we have stored. So we have removed this 12 from the front. So Q means to remove from front. So this was a very simple operation. There is another example. We will simulate it when there is just only one element in this queue, but there is still room for 4. We are not going to enqueue, we are going to dequeue base. We have already known how enqueue works. So we are going to remove this only value in this queue. So if rear is equal to 0, rear is not equal to 0, it means there is just there is one element. So we are going to store this value. So value is equal to 12. So for I is equal to front to rear minus 1, front is 1 and rear minus 1 is 0, I is equal to 1 to 0. So condition is initially false, so body will not execute and it will just decrement this rear. Decrementing by this rear means this value 12 cannot be accessed now, and it will return this value 12, and this as simple as that. Now this was the array based implementation. Now we will do the linked list based implementation, but I have always been demonstrating how singly linked list is used to implement. So let's change something here. I will demonstrate how doubly linked list is used to implement this queue, and we will perform this dequeue operation. For example, there are 3 values, and in doubly linked list we know that there is a forward and a backward pointer. So every node has got a forward and a backward pointer. The first one, the backward pointer of first one points towards null, and of last one, the forward pointer of last one points towards null. Null means there is no location, so you can have it null. In Python you use none, so it depends on language. So in algorithm we just say null. It is a generic word, it is not representing any language. So doubly linked list based implementation of dequeue, it is front, it is rear. So whenever you say dequeue, you are in fact removing the value from front. So if you are going to remove it, first save it. So we are going to say, I am not writing a complete algorithm, just consider my steps as the instruction. So first instruction is value is equal to 12. So what will be the second instruction? You see, front is equal to front dot next. So by this diagram you can write your own algorithm here. So now if this is front, we do not need this, and if this is front, then this value, the previous of this value or left of this value must point to null, and that is what we have done. So next is front dot left or previous is null. Now in fact this is front, this is rear, there are only 2 elements here. If you are using some type of counter or position or size, so you can decrement it as needed. You do not need this node, so you can free it from memory, you can delete it, and you can at the end you will return what you have saved. You will return this 12. So this is very simple operation. For example, if there was only one value in the list, so now what will be the algorithm? You see, if there is only one value, it's left or right pointer, or in other words forward and backward pointer, or next and previous pointer. You can use any name. whatever you want, will point towards null. Now what is going to happen here, you will first save this value, and then if you remove it, then front and rear will both point toward null. So these are your next statements, and then you will delete this node so that your memory is freed. So it's quite simple as that. It's very easy implementation. That is why I have not written its algorithm, because it just requires 3 to 4 statements. So it's quite easy. So then you will return this value. Now what are the application of queues? Queues are used to handle the interrupts in real-time systems. For example, the interrupts are handled in the same order as they arrive, first come, first serve. And in a scheduling algorithm, especially in CPU, you will learn in operating systems that there is an algorithm called first come, first serve. So it in fact implements this queue data structure. So all the programs have to wait in queue. So the one at the front of the queue will be entertained first. It will be given the CPU, and then all other that are in queue will be in waiting position. They will wait for the resource. So this is what queue is. And you have also seen in printer that if you give 3 to 4 commands, so it shows them in the printer box. And in fact that list is in fact queue, because the one at the top, that was included first. So it means it came first, so it will be printed first. So first come, first serve, or first come, first out. So it is same. There are many variations or many flavors of queue. So a simple queue, it can just insert at rear and read and delete, or you can say dequeue from front only. But there is a special type of queue that is called double-ended queue, and it is read as stack. So it is in this variation, what we allow is that we can remove, means we can enqueue and dequeue at both ends. So queue can grow and shrink at both ends. So it's quite it's just a concept. It's implementation is very easy. Now this thing here we will spend some time. What is priority queue? See, in a simple queue, you go in a very ethical manner. The one that came first will be served first. But sometimes, especially in our culture, these VVIPs, this VVIP culture, whenever there is a VVIP, so there is no queue, because he deserves to be right in front of the queue, because he is VVIP, he is very important, his priority is very high. So this unethical type of concept is called a priority queue. In a priority queue, you can dequeue in the same fashion, means dequeue can will only happen, it will only occur at the front of the queue, means the value which is at the front of the queue will be entertained first. But will the values be entered in the same fashion? No, there is a change. So enqueue operation is changed. So the value with the greater priority will be at front, will be inserted at the front, and value at with the least priority will be at the rear end. So this is why that's why I called it an unethical version of queue, because it implements this VVIP culture. So we save the how will we know what is the priority of each value? So it means that we are going to have an extra value that is to be stored with the original value, and that will be the priority. So it can be the you can say the value itself, means if the magnitude, if there are integer values, we are going to store integer values in array. So you can say that the values with greater magnitude, or means 99 has greater priority than 97. So in priority queue, items will be sorted. But sometime it happens that you save the priority as a separate structure. Here is, so you are going to implement this with the help of a 2D array. So the first row will be containing the values and second row will be containing the priorities. So 2D array can be used for this purpose. And in linked list you can have an extra thing, means if initially you had got just two things in a node, means just two slots in the node, one for the actual value and the second for the next one if it's a single linked list. But here you will need another one, another box for priority. So the rest is same. So for example, this is a priority queue and the original values are 12, 21, 6, 8. So maximum 5 values can be in the queue, but now there are 4, so size is 4. And you have been asked to insert a new value 0 and its priority is 11. So what will you do? You will start from rear and you will match its priority. So its priority is higher. So it means you and there is still room. So rear is not equal to max. So you can insert it. So you will shift in arrays. You need shifting, and that is the basic disadvantage. So you will shift this value to location number 5, and you will increment the rear counter, and then you will compare it with the next value. I mean with the previous value. So its priority is 8. So it means this 11 needs to be at this place, and that 8 will be moved here. So we are going to copy it here, and then it will compare with next one. So it means this 9 must be moved here, and 11 deserves to be on the left side of this 9. So when it compares with the next value, so its priority is not so much, is very very high, 20, and it's of 11. So it will not be inserted here. It will not copy it. So it will copy this 0 to the location which was free now. By free we mean we have already copied this 9 to here. So you can insert a value here. So now you see 20, 11, 9, 8, 6. These priorities are sorted. So this was a simple example. So we can also implement it using linked lists. For example, if we implement it through singly linked list, it's very easy. There are 3 values in the list, and you are to insert this new value 0, whose priority is 11. So you have created a new node for that. And what you are going to do, you are going to run a loop. So current node is equal to front. So if this is current node, what is automatically current node not next? This one. So we're going to match the priority of 10, means of new node, with priority of current node and current node dot next. So if it is in between both these, so you will insert this value between this current and current dot not next. But 10 is not in between 20 and 11. So what will you do? Current node is equal to current node dot next. So automatically this will become current node and this will become current node dot next. So its priority is 11 and its priority 9. So 10 is in between this 11 and 9. So it means this node has to be inserted in between these two. And here you will follow the same procedure that you have studied in linked list, how to insert a node. It's very easy. What are the steps? This new node dot next is equal to current node dot next, and this current node dot next is equal to this new node. And when you will do this, automatically current node dot next means this value. So if you just rearrange it for convenience, you will see this value is inserted in proper position. So 20, 11, 10 and 9. So it's just very easy. So for example, if list has just only one element, so how will you do it? If it has just one element and you need to insert a new element, so either this will be on the left hand side or right hand side. So if front is equal to rear, so you can have a special condition here. You can check this priority, that if the priority of new node is less than the priority of this front. If it is less than, So it means it will become the front node, and if it is greater than, it will become the rear node. If it is equal to this, you can go either way. You can make it either front or rear. So suppose value of priority is high. So what will you do? The value of priority of new node is higher than the value of priority of this rear or front node. So it means this has to be the front one. I think I just made a mistake, that if priority of new node is greater than the priority of front, then it means this is going to be the front node, and if the priority of new node is less than the priority of front or rear node, then this new node is going to be the rear one. So here the priority of new node is greater than the priority of this front node, so it means it will become the new front node. So first what I will do, new node dot next is equal to this front or this rear, whatever you want, it's just the same, and then front will point towards this one. So if you rearrange it, you will come to know that problem has been solved. So these are very easy topics, just the abstract topics, and I already know that you have implemented these in your lab class. So if you have got any problems regarding the concept of any of these data types, so you can contact me anytime. You can contact me through email, you can contact me on my mobile number, and you can contact me through WhatsApp group. So whatever means that are convenient to you, you can contact me, but I am waiting for your questions. So if I'm not getting your questions, if I'm not getting your queries, so how will I know that which topics are difficult for you? What are in fact the problems that you are facing while having this course? So please be honest and be fair with yourselves, and if you have got any problem, do discuss it with me. So there is just a practice question and a very easy one. You have already learned in detail what is the analysis of algorithms. How can you calculate time and space complexity of any type of algorithm, whether they are simple ones, iterative ones, recursive ones. So we have discussed many of algorithms today. So your job is to calculate their time complexity and represent it in the form of big O, and it's very easy. For example, if let us take an example. Let us take this example. So this is just a constant time operation. This is again a constant time operation, and this loop can run from 1 to rear minus 1. It means from 1, if total size is n, then this loop can run maximum n minus 1 times, and this is just again a constant time operation. So these are n minus 1 plus some constant time operation, so it is order of n. So these are very easy topics. So as these are very easy topics, that is why I have left it to you people. So I have already discussed the most difficult topics already in my course. So this must not be a problem for you now, as we have discussed it in very detail. We have spent plenty of lectures, many lectures we just spent on analysis of algorithms. So this is just a practice question. This is not a quiz. This is not an assignment. It's just a practice question. It will help you to get a better insight of the complexity of algorithms. Until next lecture, Allah Hafiz.